All right, back with the next in the Fix-It series, repair series. As I said, the next repair will be of this Hewlett-Packard quad DC power supply. Just to go over fairly quickly with this, and this thing has basically two major issues. But first of all, it has four modules: 1, 2, 3, and 4. One of the modules, which is this module right here, which I'll show, I'm going to be doing two videos, fairly short videos, showing what's wrong with this thing, or at least what it's showing. This module, actually, the self-diagnostics comes up that something is wrong with this one. But there's also a little more subtle of a problem. And that's what I'm going to be showing right now. So anyway, what I have hooked up here is I have this module number 1 hooked up to just a regular fan, 12 volt. I think it's 180 milliamp fan. I have, sorry about my cold. I have these leads, test leads here, which goes to my Agilent DMM, and I'm just going to turn this on right now, and we'll zero these out so this will get a more accurate reading. Okay, so you see now it's nice and zeroed out, and now I'm going to use my one hand and hook these up. I don't know if I can, how well I can do this, but I will try. Okay, that's one. Okay, and here's 2. All right. Now, these are fairly nice test leads, the Agilent leads connected here. And I'm going to turn this on and kind of show you what's going wrong with this particular module. This problem does not show up in the self-test. And like I said, I'm going to cut this up into 2 videos. The first one is going to be showing this problem. So, okay, let's turn this thing on. As you can tell, the fan is powering up. You have 0. And this is what the front panel displays. 0 volts, basically 0 amps. And this is how this is the real problem. Over voltage set. Now it has a very odd number here. It's basically showing 22.97. That is the over voltage threshold. Now what this thing has is it has 2 leads in the back on each module, which is an over voltage leads, and they are TTL. And if they're signaled, then it will create an over voltage condition, which will then turn that, it'll trip that particular module. And there's also another setting which you can set the over voltage threshold internally. You can actually, because they're just TTL. In other words, it's from an external source. That's not what this is. What this is you set the actual threshold and it trips when it's above that. So anyway, let's see what this does. VSET. First of all, let's set this to 1 amp. Okay. I set 1 amp it's set at, because we don't want it to be constant current. We want it to be constant voltage. Now, let's set the voltage. The over voltage set is at 22.97. So let's set the voltage to just 1 volt. Notice what it says. Over voltage. All right. Now we do have an over voltage reset. If we hit reset, it still shows over voltage. Now, what is interesting, now we'll set the over voltage to 22.5. Okay, still over. If we do over voltage reset, still over voltage. Okay. Now, let's say we set it to over voltage 22 even. Now remember, we're setting it lower. It's set to 22. Now if we reset, what happens? We've got 1 volt. It works. So let's up the voltage to, let's say, 10 volts. And what have we got? We've got the fan working, and we're at 9.996 volts at roughly 0.18 amps, which is 180 milliamps, roughly. I mean, and that's at 10 volts. It's supposed to be 180 at 12 volts. So let's set that. 12 volts. There you go, and there's your 180 milliamps, roughly. And it's working perfectly. The over voltage is set to 22. Now watch what happens when we set the over voltage to 22.5. Cuts out. Now we actually set the over voltage higher, so why would it be cutting out? Anyway, what I then went on and I swapped out. There's 4 leads here. They're basically serial leads, which comes from the GPIP board, which is the controller board, which controls these 4 modules. 2 of these modules are alike. This one and this one. And this one and this one are alike. So I swapped out the leads, and then this one works properly. So the module is not bad. There's nothing wrong with it. The conclusion is either something is physically wrong with the GPIP board, or what I think is wrong is it's not calibrated properly. Basically what I mean by that is it takes these numbers, over voltage, and it translates the set amount, whether it's 20 volts, 15 volts, what have you, to an equivalent amount which is in circuit here that the DACs are set to, the digital analog converters, which then trip using a comparator and signal back to the GPIP board. These parameters are kept in an EEPROM on this board. And I think what is wrong is this thing is not calibrated properly. And that's all that is wrong with this particular board. So that's kind of where I am. Is that, and to calibrate it, you basically need a GPIP interface, which goes here. And you put a shunt resistor across each board. I forget, I think it's like 9 ohms if I'm not mistaken. And then you can, via the GPIP interface, you can put it into a special mode and read back to it what it is registering using a multimeter. And it can then calibrate itself. Anyway, the point is that I'm going to do that later on. But that is not the main problem. I want to fix this board first. So what I'm going to do is this will be the conclusion of the first problem video for this unit. And I'm going to come right back, and I have to reconfigure everything to show you what it's doing as far as this board is concerned. So, okay, I'll be right back, and thank you all for watching.